Hello folks. In the previous video we were actually looking at observing and identifying SQL performance issues section, and in that we had done the preparation of initial data set, verifying slow query log is configured correctly, running a sample workload. So we did do that. So it's done. So a lot of things ran, I guess, and finally it said thank you. So now monitor database performance using Amazon CloudWatch metrics. For monitoring, you can use Amazon CloudWatch, which collects and processes raw data from the Amazon RDS into readable near real-time metrics. While the script is running, open the RDS service console. Okay, the script has finished running. At the DB cluster details page, in a new tab, if not already open, find the DB instance in the cluster that has the writer instance role, and click on the name to view the DB instance CloudWatch metrics. Okay, so reader instance, writer instance. So click on this, and I think in the last one day, I think you should see aborted clients, some of them. Okay, not a lot of things. Okay, local time zone. Yeah. What about the second one? I don't see much data. So explore related. One moment. There is replication lag showing up here. And there is estimated shared memory bytes going up. Some MB, this much MB. But other than that, I don't see anything else here. So 3, 6, 9, 12. So 12 metrics in each page, and there is replication lag maximum, replication lag minimum, and then there is slow handshake count, and then there is Aurora MySQL node volume bytes left total. Okay, so the left is basically, initially it was 129, 141, blocked transactions, there were a few, and then commit throughput, commit latency, buffer cache hit ratio, connection attempts, CPU utilization peaked at some point. It was like 84 at some point, and then created temp disk tables. So we're looking at actually a period of some specific period, I think. Database connections peaked, DB load non-CPU, DB load CPU, DB load relative to number of virtual CPUs, DB load, DDL data definition language throughput, latency, database max connections is around 1000 now, deadlocks, delete latency, delete throughput, a lot of data. So blocked transactions. So although all the metrics are important to monitor, base metrics such as CPU utilization, DB connections, write latency and read latency can be viewed as leading indicators. So if you type CPU utilization, I think you can see it here, it's high. And then DB connections, database connections, not DB connections, database connections, and then write latency, read latency. Write latency was pretty high. This is in milliseconds. Read latency was also high. So you should see them spiking as a result of the workload you previously started. You can click on any chart to drill down for more details and select any chart area to zoom in on a specific time period to understand the overall workload and its impact on the database. So you can actually see commit latency, CPU utilization, database connections, database load and all that. So Amazon Aurora also provides a range of dedicated CloudWatch metrics populated with various database status variables. Find the DML throughput metric and click on the graph. So in the detail overlay, you can adjust the chart as needed. Okay. So we have this Amazon CloudWatch metrics. Let's keep that here. So in general, database activity variables responsible for tracking throughput are modified when the statement is received by the server. So we can actually see throughput related stuff. Throughput. So you can actually see the commit throughput is high. Throughput, it should be high actually, it should not be low, but yeah, here you can see it's low and then later it was high. It was high here. Latency should be low, but throughput should be high, I think. Let's see, or is it wrong? So you can actually see commit throughput is high, yes. So database activity variables responsible for tracking latency are modified after the statement completes. This is quite intuitive. Statement latency, that is execution time, is not known until the statement finishes. Okay. So DML throughput. So for example, DDL throughput, delete throughput, insert throughput, network. There should be a DML throughput, I think. There's no DML throughput. Okay. Let's look for DML. Okay, yeah, there is DML throughput. Weird that it didn't show up there. Throughput. Can I see DML? Oh yeah, there it is. Sorry, I just didn't notice it. Forwarding replica DML throughput and this. So DML throughput. Okay. So you can see it's increased. Yes. Similarly, so is not known until the statement finishes. Okay. I didn't get this. Statement latency, that is execution time, is not known until the statement finishes, of course. But I didn't get what they're trying to say here. As in, similarly, find the DML latency metric and click on the graph. In the detail view overlay, you can find the exact data point details. So to learn more about how to plan for Aurora monitoring and performance guidelines, please refer to our Aurora monitoring documentation. Okay. There's a lot of documentation. Wall of documentation. So the DML latency metric reveals a spike at 12:03 p.m. when the metric reached 2 seconds, basically 2794 milliseconds, almost 3 seconds. In other words, 2.7 seconds is the maximum latency of all DML statements that finished during that 1 minute period. 2.7 seconds is significantly higher than the baseline latency observed before the spike. So therefore, it's worth investigating. A useful piece of information readily available from the DML throughput metric. At 12:03 p.m., DML throughput is 0.5, which is roughly 30 operations per minute. Okay. This could be the reason for the DML latency we noticed before. Okay. Let's look at this. So 0.5 operations per second and per minute would 0.5 operation. Throughput is this much operations per second. So into 60, there's like 1 minute. So 30 operations per minute. Okay. Once the performance baseline is understood, you can set up alarms against CloudWatch metrics to alert when they exceed the baseline, so you can take corrective actions. Okay. So let's look at the latency and the throughput. So you can actually see the throughput is pretty low over here alone. 7, 11, 15. Okay. Is there any timestamp over here? No, there's no timestamp over here. Anyways, throughput is pretty high, and then it went higher also, but then it was lower also in between. Just wondering, throughput being high is a good thing actually. Let me just look at this part. Throughput is 0.5 here. Here it's 0.5. Here it's actually pretty low, 0.1. And latency, you can actually see DML latency is pretty high over here. You actually see it's actually 4 seconds when it's 2.5, which was like 1 hour back. At the same time, so basically you can actually do this. So view in metrics. So this is a 2.5. At the same time, so at the same time, if you look at the DML throughput at 2.5, it's actually 0.7. The count per second is actually high only. Interesting how the latency is high, but throughput is also high only. Baseline throughput is 0.5. Here it's 0.7. That's interesting. I'm not sure how to read this. Anyway, so let's look at what it says next. So monitor database performance using Amazon RDS enhanced monitoring. You must have noticed that the CloudWatch metrics did not reflect the workload right away. Different metrics have differing reporting intervals. Most Aurora metrics use a 1-minute reporting interval. Some, such as CPU utilization, use a 5-minute interval, and a few even longer interval. However, to monitor and understand operating system or host level metrics, such as whether the CPU is consumed by user tasks or system tasks, or to see free or active memory with the granularity as low as 1 second, RDS enhanced monitoring is the appropriate tool to use. Okay, EM basically. So your DB cluster was created with enhanced monitoring enabled. You can view the metrics by selecting the DB cluster instance monitoring. Select enhanced monitoring option from the monitoring drop-down list. For more information about enabling and using enhanced monitoring feature, please refer to the enhanced monitoring operation documentation. It's the same link. Click on monitoring, click on enhanced monitoring. Okay, so you have enhanced monitoring now. If you look at CloudWatch, there are some 204 things. If you look at enhanced monitoring, you have this. There's OS process list and database insights. Okay, so you have free memory which is going down at this time. So is this the local times though? Page size 1232. Okay, awesome. But we don't have that many things. Thing is, let's do 1 hour or 30 minutes. No, I'll just say 1 hour. 5 minutes, 1 hour, 30 minutes, 15 minutes, 30 minutes, 1 hour. Cool. Anyways, so 1 hour. This is in UTC. Okay. So free memory increases later and then decreases. CPU user, load average, use file system and all that. Okay, so go through the enhanced monitoring dashboard. You can click on manage graphs to add more graphs to the view. Manage graphs. Okay. You can just click on everything, I think, and it should just show up everything. Transactions per second. There's a lot of stuff. Max inodes, received, transmitted, task sleeping, zombie tasks, CPU nice. What is steal idle wait system? IRQ, I don't know. Read latency, write throughput, read input output per second, write output per second, input output per second. Disk queue depth, write back memory, huge pages free, huge pages RS read, huge pages sub, cache memory, huge pages page, huge pages total, inactive memory, page tables, dirty memory, mapped memory, total memory, slab memory, buffered memory. Click this and you should see a lot of stuff and 3 pages basically. Cool, this is transmitted, this is received. There's a lot of stuff here, I don't know. It says cool, so tasks sleeping and all that. So you can select graphs that you want to add and click save. You can also use a search box to search them for metrics that you would like to review. So CPU user total, you can click on the gear icon to increase the number of graphs displayed on the page, or scroll through the pages to review all graphs. So that's the max 32. And you'll see additional counters showing metrics captured at the operating system level as well as local temporary storage, not the persistent Aurora storage volume. Okay. Cool, so dive deeper with database insights. So you need to enable advanced mode of database insights to view logs, slow queries, events and OS processes. For more information on supported modes, visit modes for database insights and how to enable. Follow these instructions. Let's see if enhanced thing is enabled. I'm not sure, I need to check. Let me click this database insights. It should say if it's enabled or not. If it says it's enabled, great. If it's not enabled, it's a problem. Aurora MySQL node 1, 2, fleet health, Aurora MySQL 2, Aurora MySQL 1. Okay, great. So this is the thing, and there are ones that are not having advanced yeah, so database insights, as you can see. So if you make it small, make this, so these two are advanced, right? So we have it enabled, so it's fine. So I think Amazon RDS Database Insights monitors your RDS daily instance load so that you can analyze and troubleshoot your database performance. To view the current database insights dashboard from the current database instance page, click the monitoring drop-down button and choose database insights. Select the DB health dashboard on the left nav bar or navigation bar to view the database instance health dashboard. Database insights health dashboard is divided into 5 sections: database load, database load analysis, database telemetry, performance analysis, calling services. I think we've seen this before. Allowing you to drill down from high-level performance indicator metrics down to individual queries, wait events, posts, databases, and users. You can learn more about database insights in the use database insights thing. Okay, I think there is some lab that is not working for some reason over here. I'll just keep it. Maybe in the future, Amazon Database Aurora Labs, my.com. Anyways. So here you can actually see database telemetry, and so if you click database instance and then database telemetry, so load top waits last 1 hour or something, I think you have to do. So let me look at last 1 hour. How can I choose last 1 hour? I think it can't. So metrics, okay, top hosts, top users, top databases, database telemetry. So here I think I can say 1 hour. I don't know where to say it. So, or maybe it just shows for a lot of time. So input output cache versus disk read and all that. So you can actually see that at 2 o'clock this got crazy. So this is based on I think UTC time. Let me see. Believe these are all UTC times, or no, probably my time, local time. Reset dashboard, refresh, logs, slow SQL queries, no log events. Logs should show up. It should show up. It does show up. So yeah. So it says MySQL native password is deprecated. Please use caching SHA-2 password. Yeah. It should show slow SQL queries. Let's see. Doesn't seem to be clear here. Let's see. So metrics, you can customize this dashboard by adding operating system metrics, database counter metrics, and CloudWatch metrics to it. You can also remove metrics from the dashboard. Start by adding additional counters in the metrics section by clicking create widget button. These metrics are categorized into OS metrics and database metrics and add valuable information on top of the CloudWatch metrics. You can provide a metric widget title and select relevant metrics from the option. Okay. From database metrics, select at least InnoDB, rows read, and slow queries. Okay. So let's look at this. Metrics, create widget. Oh, oops. Create widget, and so we're looking at DB metrics. So we want InnoDB rows read, SQL InnoDB rows read, yeah, and slow queries, right? So you can actually search for it, InnoDB. So it'll show up inserted read, and then slow queries, yeah, and then what else? From OS metrics, select at least CPU utilization total. Click create widget, and once done, so we have to give a name, OS metrics, and this one is DB metrics. So we won't be using this. Yeah, so DB metrics. Okay, and then OS metrics, CPU utilization total, and once done, the counter metrics should look like the example below. You can see CPU spike about 90%, the number of rows read is 1+1,000,000 shortly thereafter, and slow logs are getting logged for this time period. Okay, let me see. Okay, you need to look at the time period. So this is 3 hours, maybe last 12 hours. Yeah, so we can see OS metrics going up and down, logs showing up. This will only be the latest logs. Slow log query patterns, not much. Okay, interesting. Database metrics goes up. Yes, I can see it over here. So rows read, slow queries are all high. So slow query is nothing on an average, seems like it. CPU utilization was pretty high in between alone. Next, correlate these counters with database wait events to understand the workload. Scroll down to database load section. You can see different wait events on the right hand side. So sliced by SQL. So many wait events, Amazon Aurora MySQL limits are the same as MySQL Community Edition and can be found in the MySQL documentation. Aurora specific wait events are documented in the Amazon Aurora MySQL reference guide. Okay. So you can also change the view of database load section from slice by wait to slice by SQL to understand AAS. I'm not sure what is that, of different queries at this time. You can also see the max number of available virtual CPUs, okay, is 2, but the current sessions exceed the max vCPU, and this in many cases would be a driving factor for CPU or memory consumption. Okay. Finally, drill down deeper into the performance of the queries discovered above in the database load analysis tab. The default interface shows top SQL along with some statistics for each of the top query patterns. For each query pattern, you can observe the load by SQL's AAS. AAS stands for average active sessions. The query pattern text, rows examined or per call, or rows sent per call. Okay. Looks like you're not looking at this top SQL stuff. DB load analysis. There is load by weight, top databases, top users, top hosts, top weights, top SQL. Yep. Show status like uptime, select max execution time. Interesting. So go to preferences, gear icon at the right hand side, and add additional columns with additional useful counters. Add the following counters, then click confirm. Rows affected per second, rows examined per second, rows sent per second. Rows, everything about rows. So let's just click the gear icon and say rows examined, sent, rows sent per second, rows sent per call, rows examined per call, rows affected per call per second. There are some 6 things. Okay. And once saved, the session activity for top SQL would look like below. Okay. You should be able to see rows examined per seconds versus rows sent per second and corresponding average latency in milliseconds per call. Should focus on the queries with large differences between rows examined and rows sent. So rows examined must be there. So I think you're looking at 12 hours. Okay. Last 3 hours you don't have anything. Let me run this thing again. No, I want to run it again. DML latency, I want to see 30 minutes. Let's look at this, and I think we'll find something interesting, and Yeah, basically they're saying if there are many rows examined but the rows sent are pretty less and average latency is pretty high, then you should focus on the queries with large differences between rows examined and rows sent. Right? For example, the rows examined is this much, but rows sent is like 1. Because there's 12,433 rows examined, but then only 1 row is sent, like 2 rows is sent. As telemetry tab, the slow query SQL queries section provides a list of slow query patterns sorted by frequency. By selecting a pattern, you can view a list of slow queries that match the selected pattern. You can use a slow query list to identify slow queries affecting your database instance. What's inside a stored procedure? To see the queries inside a stored procedure, please click and expand the plus button, plus icon. You can note down the top SQL queries, but please keep in mind not all top SQL queries are slow queries. It only means that these queries are representing the load at a given point in time. You can use the database to understand average activity. However, to get individual query statistics and execution time for longer running queries, you should leverage the slow query log. I was a bit hard to understand, but it's okay. Something better than nothing. Like starting to understand some things. So leverage Amazon CloudWatch logs and log insights to view and analyze slow queries. So here, if you reload after every 10 seconds, you will notice that the load should be increasing, by the way. It's going to take some time, but as you can see, the latency is increasing. So DML latency, the value is basically in I think millisecond. So line, what's a gauge? It will give the current number, I think. Yeah, it's millisecond. You have to set the gauge from the options tab. Okay. So other than that, so slow queries are great for troubleshooting, but viewing or downloading individual logs could be tedious and time consuming. In addition to viewing and downloading DB instance logs from the console, you can publish logs to Amazon CloudWatch logs. With CloudWatch logs, you can perform real-time analysis of the log data, store and retain the data in a highly durable storage, and manage the data with the CloudWatch logs agent. Your DB cluster has already been configured to publish error logs and slow query logs to CloudWatch logs. Okay. So to verify that your DB cluster is publishing logs, open the Amazon RDS Service Console at the cluster level detail page and check the published logs section of the configuration. Please proceed to the next task only if you see slow query log publication enabled. Where is published logs? I think we're looking at logs and events. Oh, it's configuration, sorry. It's the same thing, so let me just close this. If I click this, will it show me the logs? Configuration, it doesn't show me the logs. But if I click the cluster, I think it will show me the logs. Published logs, published to CloudWatch, error log, and query log. Error log, you can clearly see it here. Query log is this slow query. You can actually see user host, User at host, query time is this, 82, and was it second? So rows sent is 0, rows examined is 0, and this is the load data. So this is the, and there's error logs, audit, database, activity stream, config file, trying to load okay, so enable log publishing to CloudWatch logs. To enable or disable these logs or add additional logs, you can click modify on the top right of the panel, log exports plus check or uncheck preferred logs, and then continue modify cluster. So log exports, sorry, damn it, no, we can't open the workshop one. Workshop, oh damn, I forgot the workshop access code, just a moment. Workshop, yeah, cool. So we are at this one in observe and identify SQL. So here I think it's the same thing. Let me check. 469583883083. Yeah, this is that one. So login again. Do I have the stuff that I created? I think so. I do. That's an interesting thing. Okay, cool. I think I'll keep it light. Yeah, it's okay. Cool. So now we were looking at leverage Amazon this, right? So we saw that, we saw the logs. Once you've verified that the log exports is configured correctly, okay, so you can actually export the logs apparently. Let me look at that. So it says export, copy search, download and search, download search results. Okay, I don't know if that's what we need to click. They just said export. So check the published logs section of the configuration. Please proceed to the next task only if you see the slow query log publication enabled. Okay, enabling log publishing to CloudWatch logs. To enable or disable log these logs or add additional logs, you can click modify and okay. So I think you need to click in RDS, modify, and then you should say log exports. I think log exports, yes. Select the log types to publish to, yeah. Check or uncheck preferred logs, continue modify cluster. So it's already there, error log and slow query log are already checked in, so it's fine. I think that's what they're talking about here. So once you have verified the log exports are configured correctly, you can access the logs in CloudWatch Logs. A new log group is automatically created for the Aurora DB cluster under the following prefix, in which cluster name represents the DB cluster name and the log type represents the log type. Cool. So I think this is what they're talking about. AWS RDS cluster, and then the cluster name, and then the error log group, and then slow query log group. You can actually see that this is a slow query, and then there are some more. So anomalies.csv, sample.manifest, and then select timestamp, SQL no cache, max 10. Okay, there are a lot of them. Right, so these are slow queries, and then you have errors. For example, it says found dash config file, trying to load dash switcher from dash config file and whatnot. So these are errors. For database cluster, Aurora MySQL cluster, slow query data is stored in this. Open the thing and the DB cluster log group. Okay, so I think CloudWatch Service Console. And then you have log groups, and you see this log streams. This is the slow query, so you can click log groups. This literally goes to the log group, slow query log group. And if you want to see all the log groups, it's here, and then you can actually type Aurora lab MySQL cluster. Yep, those two. Anomaly detection, data protection, sensitivity, data account, never expire, and then metric filters, contributor insights, subscriber insights, I guess. I think I'll make this smaller. I might say no to some of these things. Subscription filters, apparently it's called. Cool. So that's that. And then under the log streams tab, you pick your current writer node, since that is where workload was run against, to view the slow query logs, and you should see output similar to the example below. Yeah. So we can actually choose log streams. Where are streams? Let me see. Oh yeah, here it is. This is metric streams. I think in the log events, log groups, you have to open up slow query log, I think. So slow query log, and here there are log streams. Yep. And we have to choose the writer instance. What is the current writer? Let me check. MySQL cluster. Node 2 is the writer, so let's open up node 2, and you should see log events. Yep. And under the log streams tab, pick your current writer node. Yep, that's what we did. So here in the log streams, you have to choose your writer node, so it's 2. And if you choose 1, I think one will not have anything, because it's the reader. Only once it had one thing. Just once it had something, I think, load data. Cool. So this one, it has a lot of stuff, I think, right? So if you look at this, there's more and more, I think. Let's see if there's anything newer. Cool. So we can actually open up one of these. It says query time. Some 53 point something. Query time is 53.60 seconds. So that's a lot of time. Log time. This is the load data thing, and then there is more like 3 seconds, 4 seconds, and whatnot. Cool. So we see a lot of it. So log retention in CloudWatch logs, the default log retention period is never expire. However, this can be changed. So in our case, we don't expire it at all. So change log data retention in CloudWatch logs in the documentation. So to increase the readability of these logs, you're going to use Amazon CloudWatch Insights. Click on the Log Insights option in the sidebar menu and select your log group in the drop-down list. So Insights, and select your log group in the drop-down list. Okay, so log group name. MySQL cluster. So we have error and slow query. So for slow queries, it will be this in the next text. Okay, let's choose one actually, just slow query, and then in the text field, enter the following insights query by replacing the writer node placeholder with the database instance ID name of your active writer node cluster in the cluster. So copy this, and we'll say MySQL node 1. Okay, so we'll remove this. So it says field timestamp message log string log. Okay, sort timestamp descending, limit 10,000. So instead we have this, and we'll say Aurora lab MySQL node 2. Okay, and parse message, yeah, log time and all that, rows sent, rows examined as this, and then run query. So we're gonna get some data now. Yeah, we got it. So this has, so we parse it and then we get it. So yeah, here you can actually see how it gets the data when you say time, and then there is what do you say, time, user host, query time, user at host, ID, and then query time, ID, query time, log time, rows and rows examined, right? And then finally timestamp equal to the rows examined, and then timestamp equal to so that's pretty cool. And then the query basically in between. I think, how did they get the query though? Timestamp and then finally the query. Okay, so and then they display the time, query rows sent, rows examined, right? So here you can actually see how the time here, this is the latest, these are older, right? So this is rows examined, and then it says set. Okay. And this is parsed from this thing. So rows examined is basically this along with set something, right? So yeah, timestamp equal to this, and then finally the query. So you can actually see that the query is, oops, message is this. Anyways, so now one thing I can do is basically I can say here I can say set timestamp, so that we can pick out this thing. So it's actually set timestamp equal to, so rows examined and then set timestamp, so that this set does not become part of the rows examined, right? So I'll just say set timestamp. So let's run the query and see if it shows. Oh no, nothing shows up. If I do this, it does work. Interesting. Rows examined and then it says set. Okay. Anyways, cool. What else? One moment. So the next thing is basically you should see rows examined, see set also comes up. Anyways, the output should look similar to the example below. Okay, yes it does. So only the queries that take longer than the parameter value of long query time, see below listed, see above, will be listed. You can select any query and expand to find more information about it, and then you can download the table, by the way. So you can also export the results into a CSV formatted file. For easier analysis, click export results and choose download table. Name the resulting file slow query log2.csv and save it in a memorable location. So you can actually export the results by CSV. I would like JSON actually. So slow query log2.json. Cool. And okay, so now download slow query logs. So in this section you'll learn how to view the slow query logs using the AWS management console. Since the workload script was run against the cluster endpoint, which points to the writer node by default, you should check the writer node logs at the cluster detail page and select the writer node in logs and events log section, and you should see these. Okay, so MySQL cluster, logs and events, there is okay, slow. Yeah, I can see something over here, so I can click this. You can select the slow query log file for the time frame and view or watch it. Below example shows the log when you view it. Slow query log, view it, okay, back, slow query log, watch it, okay, If you click it, I think it's just view. If you watch it, it's hover reached the end of the stream, so I think there's not much. Log files are rotated automatically. Hardly the information you're looking for may not be in the current log file. Find the log file for the time your workload has been running and when the events you need to investigate occurred. So this one is done, by the way, so I can just copy this and put it here. I think that is already done. And then so you can see the thing. So you should see slow queries in the console. The log file will also include the following: query time, log time, rows sent, rows examined. Okay. So the statement execution time in seconds, the time to acquire logs in seconds, the number of rows sent to the client, the number of rows examined by the server layer, not counting any processing internal to storage engines. To learn more about slow queries, please check MySQL documentation. Oops, let me close that down. So this, okay. So you can download slow query logs via the AWS management console or the AWS CLI using the download db log file portion. Okay, it's a CLI command. Okay. API call. Use the Amazon RDS service console to locate the slow query log file that contains the desired events and download that file by selecting it and clicking download. Rename the file to slow query log1.log and save the file to a memorable location. Okay. I don't know why they're storing all these log files. Monitor database metrics using performance insights. Okay. I think after this we should be good with looking at other stuff. Anyways, we still have a lot of things: security, global databases, machine learning, serverless, upgrading, zero ETL. Cool. So this is an optional lab. AWS has announced the end of life for performance insights. The Amazon RDS also provides a consolidated view of performance insights and CloudWatch metrics for your DB instance in the performance insights dashboard. You can choose the monitoring view in the monitoring tab or performance insights in the navigation pane. Okay. Sign into this performance insights. Okay. So interesting. Let me click this. Where do I find performance insights? RDS console. It's here. Performance insights. So on November 30th, this is here. It's not selected yet. Okay. So expand the drop down and choose the writer instances where the load is running. Expands on existing Amazon RDS monitoring features to illustrate and help you analyze your database performance. With the performance insights dashboard, you can visualize the database load on your Amazon RDS DB instance, load and filter the load by weights, SQL statements, hosts, users. So MySQL cluster, MySQL node 2. Okay, so on the performance insights, scroll down the page and click on metrics tab. Under the metrics dashboard, so dimensions, top SQL weights and all is there. So 7 of them. Top SQL, there are some 6 of them. And then top hosts is just one of them, of course. Top users is also just one of them, of course. Then top database is just one of them, like, of course. And then metrics. So under the metrics dashboard, select a pre-configured dashboard from the drop-down list. Okay. You can view the metrics for the DB instance in the dashboard. The following examples shows a pre-configured metrics dashboard. So pre-configured, like health summary is one, custom dashboard, you can create your custom dashboard. Pre-configured dashboard is the health summary. So you can see CPU utilization, free memory, out of memory kills, kills basically. And they have a lot of things mentioned here: CPU utilization, free memory bytes, and then input output latency in milliseconds, input output operations per second, input output throughput bytes per second, and then InnoDB history list length, logins, connections, sessions, queries per second, query latency in milliseconds, query throughput per second, and then buffer pool hit ratio percentage, active transactions versus logs transactions, data modification language, DML rows per second, and then input output cache versus disk reads, pages per second, row lock time milliseconds, deadlocks per minute. So you can also create a custom dashboard. The customized dashboard supports up to 50 metrics. To create a custom dashboard, select the custom dashboard from the drop down list. Choose add widget. To open the add widget window, you can open and view the available operating system metrics, database metrics in the CloudWatch metrics in the window. So you can just click this and then click on add widget, and I don't know, you can actually just choose all of this, or just say CPU total for example, and then database metrics, say SQL, slow queries, InnoDB, or rows, inserted, read, write, and then logs, cache. What else can we do? There are a lot of things and a lot of CloudWatch metrics that they have provided here. So DML stuff, TDL stuff. Now, for example, DML throughput, latency, and all. Right? There's a lot of things. You see, add widget. I think. Oh, that's a lot of things in one go. I think I'll delete it. You can have one thing in one. For example, you can just have slow queries in one, and then you can have one more for CPU utilization. So, and then select the metrics that you want to view on the dashboard and choose add widget. You can use the search field to find a specific metric. Selected metrics appear on your dashboard. The following example shows the add widget window with the metrics. So Aurora, bin log, replication lag, and all. So if you want to modify or delete your dashboard, choose the settings icon on the upper right of the widget and then select one of the following actions in the menu. Edit, modify the metrics list in the window. Choose update widget after you select the metrics for your dashboard. Delete deletes the widget. Choose delete in the confirmation window. So if you want, click this and then delete, or edit and update widget, or just delete. Right, and delete. So you can do that. Yeah. One of the following actions: edit, to modify, choose update widget after you select the metrics for your dashboard. So once you're done with all these summaries, so in this exercise you have used RDS monitoring tools like CloudWatch metrics, enhanced monitoring to understand the database workload. So RDS performance monitoring tools like performance insights and its counters to understand the workload. MySQL slow query logs using RDS console, AWS CLI, CloudWatch log insights, and Percona's toolkit, PT query digest to understand the pattern of queries. So in the next lab, you'll learn what to do with the captured slow query logs to analyze the query SQL query performance. So yep. So actually we downloaded it twice, I think. I think here when we downloaded, it said here we downloaded the CSV, is it? I remember downloading, I didn't download this. Okay, I think I'll download this one as I think I downloaded this JSON. Let me see. So slow query log in CloudWatch log insights. Okay. CloudWatch log insights, log groups. Nope. Nope. I don't need it. I don't need this also. Event list. Nah, it's okay. This I'll come back to it. So here there was a lot of stuff mentioned here, right? We were running something over here. So this is some sort of query, and I think we can actually we can close this, and I think this came up already. Okay, run. Okay, sweet. Maybe yeah. Cool. So if you run the query thing, you should be able to see the logs, and I exported it as JSON actually. Yeah. This one I exported it as JSON. The other one they said export it as another thing, CSV. I think I'll also get the CSV. Slow query log 2. Slow query log 2.csv, or just this. Okay, .csv. Okay, and now this one I can go to RDS console, monitoring. Oh no, logs and events. Configuration published logs, is it? So logs and events. There is logs actually over here. Logs and events, recent events, and then damn it, where are the logs? I have to choose the writer node. Okay, sorry. Recent events logs, and then slow query log, right? I don't think this one has anything, does it? No, it doesn't. So slow, and choose this, and then you can select thing, view or watch it, view it. To learn more about the queries, download Amazon RDS console, locate the slow that contains the desired events and download the file by clicking download. So you can actually just click download over here, or you can open it and also click download, I think. This doesn't have anything. Wow. This is for the writer, right? Writer instance. Slow query log. Time ID argument. Okay. That doesn't make sense. Oh, I think there are newer things. This is less. Let me actually put it by size. Yeah, this is 38 KB. Yeah, this has something. This is 38 KB and 680 bytes. Okay, that's a lot of data. This is also a lot of data. This is also a lot of data. 1 KB is also a lot of data. 680 bytes is not much, I think. Yeah, it's not much. This is also not much. This is also not much. This is also not much. This is a lot, yes. This is also a lot. Cool, so I can actually download this. I'll put it as 1, 2, 3 something. Slow query log1.log. Okay. Log1.log, log2.log. Slow query log1.log. Okay, and then this one .09. Cool, so we have slow query 2 and this one is log1. Okay, cool. So now let's actually go ahead and analyze SQL query performance. So there are a lot of optional things. It's okay. We'll also be doing a lot of interesting graviton and stuff, and then some security stuff, database activity streams, global databases, machine learning, and serverless upgrading and stuff. Cool, so now this lab will demonstrate how to troubleshoot SQL performance related issues using different tools. More specifically, you will learn how to leverage SQL execution plans, MySQL profiles, and the MySQL performance schema to analyze queries and determine the cause of performance issues. Okay, you'll also learn how indexes can help in improving the performance of your queries. This lab contains the following tasks: get slow running queries, analyze queries using MySQL to explain, profile a query in Aurora MySQL, review available indexes, tune slow queries, review performance, diagnose issues using the MySQL performance schema, understand the workload using process list, diagnose issues with the InnoDB monitor logs using the information schema, summary. Cool, so now in this section you will learn how to investigate the slow queries captured in the previous sections with the help of explain and profile. So if you have completed all tasks in the previous lab, observe and so you should have 3 slow query log files. You can read and identify slow queries from either of them. Okay, so do we have 3? I remember having only 2, but anyways, they mentioned only 2 slow log query files. Slow query log files. Like I remember this one being one. It's interesting how only if you go to this thing you'll get it. If you just say workshop, it won't go. If you do this event dashboard, interesting. Just have to say event dashboard, event, that's it. Just have to say event again. And dashboard, and it should go. Cool. So here we noticed that you can actually save it. This is one, and then later you can save it, get the second one. I think this is one. Yeah, to analyze. So here you actually download it again, I think. After doing this, I think you download it, export results, and then download it. I downloaded it as JSON. But is there anything before this though? Dive deeper, monitor, run a sample workload, database insights. Is there anything to download? Nope. Download? Nope. Only 2 files. They say 3 files, but anyways, I still have 3 files though. You can read and identify slow queries from either of them, but for the purposes of this lab, regardless which one you use, it should contain the following queries. Update weather set max temp. Okay, so let's actually open this up. Let me actually, oops. I don't know why I had the terminal open, but so now I can actually go to downloads and I can choose these, right? And you can actually see that there's also a JSON file that I have. I have 2 JSON files, one CSV file also. So I have a JSON and CSV file too, which I can open in with Visual Studio Code. And so now from here I can actually find out these update weather set. Okay, update weather. Oh yeah, MySQL MyLab dot weather. There are a lot of these. Set max temp where ID is equal to, right? Call insert temp. Call insert temp. Okay, yes. Insert into weather values. Insert into. Insert into is not there, huh? I think insert into is not there, but call insert temp is called, and that will internally call this only, I think. Delete from weather where, so delete, no. Interesting how it doesn't show that though. Delete, it just shows call insert temp, that's all. Select SQL, yeah, select SQL no cache. Yep, there's a lot of them. Yeah, a lot of them. And then it's a range query. Map is greater than 42 and ID is this. Cool. This is a point query, exact specific thing. For the purpose of the lab, call this slow query final log. Optionally, you can also go ahead and run the above queries individually on the terminal and see the individual response time. Okay. So we can actually see how much time this takes. So go here and so this is the MySQL cluster. Let me run this. This takes quite some time. Can you see that? It says it took 4 seconds. That's a lot, right? And you can actually call insert temp. So it took 4 seconds. One row got affected, right? And can I see help? System print current command, send command. Okay, edit. And so basically insert into and delete from are being called because of this call insert temp. So let's just call that directly and see how that goes. Key value, unknown column, key value. Actually, key value has to be computed. Anyways, I think we are trying to do just a moment. The log. Yeah, for example, here you can see insert into basically declare key value. We need to run all of these. Oh, this will only work inside a procedure, I think. Anyways, cool. So we can't run that just like that now, but it's okay. And then finally, this will still run. Yes, can run this. This will take some time. This takes 2 seconds, almost 3 seconds, and this one takes 2.75 seconds. Okay, cool. So the thing is, I think it's mostly because there are no indexes defined or indices defined. So analyze queries using MySQL's explain. So explain statement provides information about how MySQL executes statements. So explain works with select, delete, insert, replace and update statements. So okay, let's look at that. Select, delete, insert, replace, update. Okay, so select, delete, insert, replace, update. Cool. So we can connect, and then now we can say once connected to the database, capture the explain plan for the above slow queries using syntax. Go ahead and capture the explain for the above slow queries using syntax. This below is an explain plan for query Q4. Okay, so you can actually say this. So let me actually copy this whole thing and have it. So when you say explain, it says select type is simple, table is whether, okay, partitions null, type null, possible keys null, rows these many, filtered one, using where. Okay, so now you'll notice these, right? So type all, select type is simple, right? And type is all, key is null, possible key is null, rows is 3 million. The explain plan has multiple fields, and the most common ones to look for are type. Provides that the database would need to perform a full table scan to run the query. The type, basically all, it would need to consider all rows. So fields, possible keys and key indicate that the table does not contain indexes that could be used during query execution. The rows field shows the number of rows to be scanned, over 3 million in this case, right? The rows were retrieved from the storage engine InnoDB and matched by the database engine itself against their predicates. This is indicated by the clause using where in the extra field, right? So using, oops, I lost it, wait. So it says using where, right? So no storage engine optimizations were used to filter rows before they are presented to the database engine, right? So in this example, the estimation of rows to be scanned is very high, and there are no keys present in this query. So the database engine will process all rows to find the matching ones. Thus, processing this query will be slow. You will arrive at similar conclusions for the other slow queries identified. Using explain as JSON. If you are interested in understanding how subqueries are materialized. Interesting. So, oops, I closed that. Sorry, one moment. Workshop, event, dashboard, Yep, so here we were looking at this analyzing query performance, explain. Right, so now the next thing is profile a query in Aurora MySQL. So we can actually use explain as JSON also, looks like it. For example, you can just say format equal to JSON. So here you can actually say explain and then format equal to JSON. Let's bring this here. Let's bring this here. Format equal to JSON. There's no example. Okay, so I'm not sure how we can use JSON exactly. I think it says this, and so maybe we have to say JSON initially itself and then the select statement. So format equal to JSON. Oh yeah, that's right. We need to give it that way. So now it says what to do. Select ID 1, cost info, query cost is pretty high, and read cost, evaluation cost, prefix cost, data read per join 7 million or 7 MB, I don't know which one. Used columns, ID, station name and type. So ID, station name and type. Cool. So that's the JSON. That's the JSON version. So JavaScript object notation JSON version, not JSON. JSON version and JSON version. So JSON format for the explain, and profile a query in Aurora MySQL. So here, to investigate where these slow queries are spending their time, you can leverage the MySQL query profiling feature. There are currently 2 ways in MySQL to generate query profiles. One of them is being deprecated. Toggle between the tabs below to check out both. So looks like this is being deprecated. Show profile. Okay. The following example demonstrates how to use MySQL's performance schema statement events and stage events to retrieve query profiles. Okay, so we can actually go ahead here and interesting. So you can learn more about how to use performance schema at the bottom of this exercise. Ensure the statement and stage instrumentation is enabled by updating setup instruments table. So performance schema setup instruments set enabled, yes, timed, yes. Some instruments may already be enabled by default. Also ensure the event statements and event stages consumers are enabled. Some consumers may already be enabled by default. Update. I think I can look at this. Let me select star from set of instruments. My lab, the set of instruments doesn't exist, but performance. Performance schema dot. Interesting. There are 1,243 rows. 1,243 rows. So there are different rows with different settings. So we're going to be looking at set enabled yes, timed yes, where name is like statement. Okay. So we're going to look at statement. Limit 10. Interesting. This has a lot of rows, so I'm not able to actually run many things. Let me actually see if I can actually run here. Select one. So let me see if I can actually run a query. How can I just run from here? Run MySQL commands. So how to run MySQL command from terminal? You have to say -e and do this. Okay. So great. I think it's -e. Execute name. Execute command and quit. Disables force and history. Okay. Cool. So I'll just say execute, and then just do this. Cool. So that is good. So here I can actually say this and put the data in performance schema dot setup instruments dot log. Cool. So do I have it now? That's taking a lot of time. Yeah, it's here. Cool. It looks like I do have it. Oh, that's just limit 10. I want everything. So I'm just going to go ahead and remove the limit. Will it still run this? Yes, it does. Cool. So we have a lot of things here. So let me just copy this and put here. Yeah. Or I can actually just say, this has to be performance schema. Yeah. Cool. So now I'm gonna actually just download this. Okay, download. Not here. Here. Cool. So then I can open it. That's where the console came from. So I think I'm just gonna open up this and I'm gonna say performance. Yeah, this one. Cool. So this one, if I just simply open it like this, if I close it and I still open it like that. Anyways, so here I'm looking for just close this. Oops, no. Close this and close this. So here I'm looking for statement, right? So statement. So for everything statement we have to enable it, right? So we're saying set enabled yes and timed yes where name like statement and stage. So statement, we say for all of this, some of them will be enabled already, I think. So as you can see here, a lot of it is already enabled probably. Let me actually try one thing. Interesting how this does not have these. How come? Can you actually say MySQL -h file output in table format? Okay. Write more gives the table output format. Okay. So can I get the table format here? Table. Can I actually say table format and then say performance this? Will I get it properly here? Oh yeah, awesome. I just download it again. Download, save. This is a newer one. I'll just open this up. Cool. So here I just need to say statement, and here you can actually see it says yes, progress. Okay, see, the first two are, can I actually make this sticky? I don't know how do I make it sticky. Copilot, nope. Sticky, toggle sticky scroll, toggle editor sticky scroll. I need sticky scroll. I want this to be sticky basically. But anyways, so the first two are basically enabled and timed, properties, and then flags, volatility, documentation. Okay. So I'm looking for statement. So these are enabled already, by the way. So but yeah, in case it's not, then you can just enable it and ensure it's enabled. So there are a lot of these. So and then stage, they're enabling it and timing it also. and then for event statements, and then event stages also, right? This is in setup consumers though, not in setup instruments. So let's look at stage, and then let's look at the other ones next. Stage. So this is event stage summary. Oh, this is yes and null over here. Okay. So we have to actually enable these, right? And then finally for this. So let me run these, by the way, so that we can actually see MySQL. So I'm just gonna go ahead and go inside here and run these and then get it, right? So I wouldn't know what was the previous thing, but it's fine. Only here, only 2 rows and 3 rows affected. That's fine. I could have gotten the values, initial values first, but that's okay. So here you can see actually 120 rows got affected for the stage thing, and statement also 22 rows got affected. Interesting. So statement. Oh yeah, actually these are not the only statements, statement slash. There are other statements also like this with underscore and all that in front of it or behind it. Interesting. Okay, so there are quite some which had null, null, null. So this is 2, 4. So let me actually get some of these. Anyways, so you can actually see that a lot of them got changed. I'm gonna go ahead and run this. So we can actually look at these next by closing this and then saying something like this one would be setup consumers and then event statements and all that. So setup consumers is what I need. Consumers, cool. So I've got it. This is pretty small. I need my terminal. View terminal, control this. Okay, so let me just download this up. Okay. Cool. So here you can actually see that events statement and event stages, right? So events statements, okay, and then events stages, they're all set to yes. I don't know what it changed then. It has changed though. Oh, now it has been set to yes. Of course, after setting yes, of course, if I get the value, it will be yes. I think previously it was something else. I don't know which one was like not enabled, but some consumers may already be enabled by default, but it's okay. Consumers and instruments and all, like they say, some instruments may already be enabled by default. Also ensure this consumers are enabled. Some consumers may enabled by default. Okay. So run this slow query statement that you want to profile below the process for query 4. Let's run this now. Let's get rid of these and run the query. Okay. And then identify the event ID of the statement by querying event statement history long table. Okay. So where SQL text like eagle mtn. Okay, so this is the event ID. Okay, query the events stages history log table. Okay, so I need to actually take a break now, and then I'm gonna actually look at these, reviewing the available indexes and all that, or indices. That's how you say multiple indexes. I'll see the next one, and I need to actually keep track of these SQL statements because I'll need them probably later. Um, cool. So let me actually pause here, and I'll start up again in another video. I'll see you next one. Bye bye.